Okay, let me start with problem page 282, problem 4. Okay, this problem says two blocks of masses m and 3m are placed on a horizontal frictionless surface. A light spring is attached to one of them and the blocks are pushed together with the spring between them. A cord initially holding the blocks together is burnt. After this, the block of mass 3m moves to the right with a speed of 2 meters per second. What is the speed of the block of mass m? Find the original elastic potential energy in the spring if m is equal to 0.35 kilogram. Okay, so هيدا النوع اللي انتو شايفينه قدامكم هيدا بيشبه الاكسبلوجن لانه انا كان عندي شيء كان عامل سيستم واحد وانفصل. Okay, so in these cases I can apply the conservation of mechanical energy. So the conservation of linear momentum. بعدني اخذ لساني على mechanical energy. So let me apply the conservation of linear momentum to find the velocity of m. I'm searching for the velocity of m. So P apply conservation of linear momentum للسيستم كله. Okay, linear momentum of the whole system. So I will get P before equals P after. I call them P equals P prime. شو عندي أنا؟ Before كان عندي ال m at rest ب 3m at rest, so it is 0. هلا you can use algebraic values كمان ما في مشكلة, so it is 0. You can use it. After شو عندي؟ عندي اثنين. عندي أول شيء عندي ال m ماشي بسرعة v, so it's m v زائد 3m ماشي كان بسرعة رح سميها أنا. I will call it, what shall I call it? Well, it's called v1 and v2. v1 and v2. Okay, so each time you see collinear collision يعني ال velocities على نفس الخط, you can use algebraic values, ما عندي مشكلة أنا. Okay, so I will get 0 equals m. أصلا فين نطير ال m من equation, so I will remove it. قسمت على m all the line. I will use algebraic values يعني بدون ال vectors. So v1 اللي هي v أصلا plus 3 v2 implies v2 equals minus v1 over 3. وال v1 كانت معي قد ايه؟ هي مسميها هو معي أنا ال v2 معياته, so I must invert it. Sorry for this mistake. Okay. أنا عم فتش على v1, so implies v1 is equal to minus 3 v2. It's equal to minus 3 times v2. It's 2, so it's minus 6 meter per second. So this is the speed. يعني هيدا بيعني إنه البلوك اللي حسميها 1. This is 1. This is 2. So البلوك 2 رايحة بعكس البلوك 1 على الشمال بسرعة 6. This is the answer. It's easy. For part B, in part B it says find the original elastic energy if the spring in the spring if m equals 0.35 kilogram. هلا هون هيدا النوع من الاكسبلوجن هو عبارة عن you can say it's somehow it has a conservation of mechanical energy. ليه في عندي conservation of mechanical energy؟ لأنه في spring بالسؤال. دايما السبرينج بيعمل نوع من elasticity وما بيخلي يصير في عندي loss of kinetic energy, so loss of mechanical energy. So in this case, to find the energy that was found in the spring, okay, I have to apply the conservation of mechanical energy before and after. ليه ما استعملت الconservation بس of kinetic energy؟ لأنه في عندي spring بالسؤال, so I have to take the spring into account لأنه الانرجي اللي كانت بالspring وين بدها تروح؟ ما تبقى. اوكي, هو بالأساس فعليا لما عملوا قاعدة الإلاستيك كوليجن أو الإلاستيك كوليجن أو خليني أقول الconservation of kinetic energy, بلشنا نحن من فكرة إنه هل الميكانيكال انرجي ثابتة؟ اوكي, وقتها إذا أنا ما عم بحكي عن الإي بي جي, ما عم بحكي عن الإي بي جي لأنه أنا ما مشيت. اوكي, so if I'm not talking about EPG, بشوف هل في EPE بالسؤال. إذا في عندي elastic energy I have to take it into account. سو رح يطلع هون معي بهيدا السؤال in part B بقول ال E mechanical before it's equal to E mechanical after. سو رح يطلع معي before ما كان عنده لا kinetic ولا APG، كان عنده بس elastic، so it's half kx squared equals من بعد ما خلصنا ما عنده elastic ولا APG، عنده بس kinetic، it's half mv squared that's a v1 squared plus half 3m it's v2 squared. so بعتقد معنا كل شيء، معنا الام it's 0.35. so بيطلع معي بالاخر فيكم تحسبوها 8.4 جول. check the answer please. so this is the answer. وفيكم تعوضوا ال V1 بقيمتها -6 مش مشكلة، وال V2 بقيمتها اللي هي كانت معي 2 كمان مش مشكلة. اوكي الام you have it 0.35. رح ارجع اعيد شغلة. بحالة الالاستيك كوليجن نحن قلنا انه نحن بنحكي عن الاي كي اذا ضامنين انه الميكانيكال انه البوتنشال ما رح يتغير. اوكي بس لما يكون في فعليا بوتنشال عم يتغير، في بوتنشال عم يتغير لازم اخده بعين الاعتبار. اوكي هلا هيدا السؤال فريد من نوعه، ما في ولا سؤال مكتوب بالكتاب، بس هيدا السؤال هيك. so this is a particular case، هي منا النورمال كيس، this is a particular case. انه باغلب الاسئله بيكون before و after، يعني ما في spring بالسؤال وما لحق مشي، so الاي بي جي او الاي بي اي مش موجودين، there is no variation of EPG no variation of EPE. so انا بس بيهمني variation of VK. بهيدا السؤال بس الوحيد اللي بيمرق فيه انه انا بهمني الالاستيك انرجي اخدها بعين الاعتبار، لانه I cannot neglect it، لانه بالاساس لما بدي قارن before و after لازم قارن الميكانيكال، بس لما ما يكون في potential بقارن الاي كي بس لما يكون في potential I have to take it into account. هذا هو باختصار هدف هيدا السؤال، وانا ليه حليت هيدا السؤال. Okay, let me كمان do problem 20. بقلنا the two blocks are free to slide along the frictionless wooden track ABC as shown in figure 9.20. The block of mass M1 equals 5 kg is released from A. Protruding from its front end is the north pole of a strong magnet, repelling the north pole of an identical magnet embedded in the back end of the block of mass M2 equals 10 kg. So we've got M2, M1 عنا إياها 5 kg، عنا ال M2 it's equal to 10 kg، واللي عنا ال V2 هون كانت initially 0 وال V1 بعد ما بعرف. so بيقول لي هون initially هون ال V تاعتها 0. so هون at rest كانت I guess it's released from A is released from A. okay so بيقلنا the two blocks never touch. calculate the maximum height to which M1 rises after elastic collision. after قال لي كلمة elastic. هلا كل هذا الحكي اللي حكيه وما بعرف شو magnet north pole وما بعرف شو الفكرة منه. بالام 1 والام 2 محل بدهم يخبطوا بيكونوا حاطين مغناطيسين، مغناطيس على الام 1 وماجنت على الام 2، ماجنت على الام 1 والماجنت على الام 2. هدول اثنين ماجنتس بعكس بعض، واحد نورث وواحد ساوث، بشكل انه لما يخبطوا ببعض ما هن بيعملوا ريبولجن. الماجنتس ما بيخبطوا البلوكس ببعض بقوه بشكل يعملوا loss of energy، فبتصير الخبطه بيناتهم ناعمه بشكل انه بيضل الانرجي is conserved. سو كل هالحكي اللي هو بيحكيه انه انا حاط ماجنتس وكذا بس ليقول لي انه هو عمل الاستيك كوليجن، وهو ذكرها تحت باخر السؤال انه هو عمل هيدا الاستيك كوليجن. هلا انا بدي اشوف الام 1 قد ايه رح يرجع يطلع لفوق من بعد الكوليجن. بدي اقسم البروبلم لثلاث مراحل. اول مرحله الام 1 كان فوق وصل لتحت، بطبق conservation of mechanical energy لانه انا عندي no friction. بعدين صار الكوليجن، كل وحده راحت بحال سبيلها، الام 2 مشيت، الام 1 رجعت لورا. هلا برجع المرحله الثالثه، الام 1 طلعت لحالها لفوق، بعالج conservation of mechanical energy. شو بعالج؟ conservation of mechanical energy، collision، conservation of mechanical energy. بقسم البروبلم كلها لثلاث مراحل، وبحاول لاقي الانرجي او لاقي الفيلوسيتي مره بعد مره. اول شغله رح اعملها لما الام 1 سلايدز لحد الام 2. اوكي ام 1 سلايدز تل بي، هي وعم تعمل سلايدنج. بهالحاله الاي ميكانيكال تاعتها is conserved لأنه ما في عندي non-conservative forces is conserved. So ال E mechanical تاعتها على ال A it's equal to E mechanical لإلها على ال B. طيب شو عندها mechanical على ال A؟ كانت at rest عندها بس height so it's half M1 it's particle 1 M1 sorry it's ما عندي kinetic عندي بس height so M1 G H equals لما توصل هي على البي شو عندها عندها energy عندها بس الكاينتيك so it's half M1 رح سميها V1 squared so M1 with M1 is cancelled I will get V1 equals radical 2GH so it's radical 2 times 9.8 مع it's 5 so we can get the answer it was 9.9 meter per second. اوكي وصلت لحد هيدي تانية هاي صارت الام 1 هون هيدي الام 1 هلا بدها تخبط الام 1 عندها السرعة الام 1 في 1 وهالفي 1 مثل ما شايفين هي على اليمين قيمتها 9.9 متر بير سكند. اوكي هلا شو بعالج؟ بقول الام 1 and m2 collide elastically. رح يطلع معي انا ال V1 ما don't do the relations just memorize the answers. V1 prime equals 2m2 V2 plus V1 m1 minus m2 على m1 plus m2. هيدا collinear collision يعني الاثنين على نفس الخط so ما في داعي للفيكتورز I just can use numbers so I will just substitute for numbers. الام 2 معي اياها والام 1 معي اياها بعتقد الام 2 كانت معنا اول شيء الفي 1 كانت معنا 0 الفي 2 كانت معنا 0 so I will remove this one والفي 1 كانت معنا 9.9 الام 1 بس اشوف قديش السؤال كانت معي الام 1 it was I guess 5 okay so V1 اللي هي 9.9 5 minus 10 over 5 plus 10 okay we will get our answer which is minus 3.3 meter per second. لما يطلع معي ال V1 prime negative هيدا بيعني انه اتجاه ال V1 prime انا كيف انا كنت اخذ ال V1 prime positive يعني البلس تاعولي هو هيك يعني انا اخذ الاكس اكسس على اليمين لما يطلع معي ال V1 positive so I mean انه هيك الاكس اكسس او هيك البوزيتيف ساين تاعولي انا كل شيء بيطلع معي نيجاتيف هيدا بيعني انه رح يرجع رجوع بعكس الاكس اكسس اللي انا بلشت فيه. اوكي هيدا بيعني انه الام 1 ما رح تلحق البي من بعد الكوليجن رح ترجع ترتد وتطلع على الانكلايند بلين. اوكي سو لقيت ال V1 prime هلا I can find V2 prime رح اكتب لكم اياه but you don't need it. V2 prime it's equal to 2m1 V1 plus V2 m2 minus m1 على m1 plus m2 قلت ال V2 كان 0 هيدي رح طيرها يبقى معي it's equal to ال m1 قلنا 5 ال V1 قلنا 9.9 على 15 so we will get the answer. ما بعرف مش حاسبيته انا anyway we don't need it. هلا الحالة الثالثة انا بدي بهمني ال m1 قد ايه بتطلع ارتفاع من بعد الكوليجن بقول له M1 goes up the أنا مسميه the track because ال V تاعيتها من بعد الكوليجن نيجاتيف يعني رجعت لورا so ما راح تكفي تلحق ال M2 راح. هلا شو أنا بطبق هون هيدي لحالها أنا خلصت ال M1 M2 ال M2 راحت بحاسبي لها على اليمين ال M1 رجعت لورا بسبيد معينة. So I now apply the conservation of mechanical energy بقول له ال E mechanical إذا بتكون على ال B بتساوي ال E mechanical على البوينت رح توصل رح سميها C إذا بتكون C so I will get ال E mechanical على ال B. هلا هي لما انطلقت كان عندها بس kinetic ما كان عندها EPG أنا أخذ الريفرنس تحت بالكعب so I will get half M1 V1 prime squared وسرعتها هي السرعة اللي أخذتها من بعد الكوليجن هلا لما توصل على البوينت سي انا ما بعرفها البوينت سي which is the maximum height بالنسبه لإلي. It is m1gh. So m1 is cancelled. Let me call it h على c. So h على c it's equal to v1 prime squared over 2g. It's equal to أنا حسبتها ال v1 prime مع إياها ناقص 3.3 squared over 2 times 9.8. يطلع معنا الأنسر which is 0.556 meter. So this is the speed after collision. فعليا البوينت C بتجي أوطى من البوينت A، يعني بتجي شي مطرح هون 0.5 يعني هون شي this is C. اوكي لأنه هي 0.5 meters، هون احنا كنا 5 امتار. anyway نزل بسرعة 9 وطلع بسرعة 3، فإجباري يطلع مسافة أقل. Okay, this is for this problem. Now I will solve problem 21, page 284. A 45 kilogram girl is standing on a plank that has a mass of 150 kilogram. So the mass of the girl is 45 kilogram and the mass of the plank is 150 kilogram. The plank is originally at rest. It's free to slide on a frozen lake, which is a flat, frictionless supporting surface. The girl begins to walk along the plank at a constant speed of 1.5 meter per second relative to the plank. So the speed of the girl with respect to the plank, it is 1.5 meter per second. This is not the speed of the girl with respect to an observer standing aside on the ice or on the frozen lake. It's the speed of the girl with respect to the plank. يعني البلانك ماشية. If the plank is in motion, this is the speed of the girl with respect to the plank, but not for an observer who's standing aside. So when he gives me something like this, he means that the v of girl minus v of plank is equal to 1.5 meter per second. In part A, he says, what is her speed relative to the ice surface? We have to find the speed of the girl with respect to an observer which is sitting aside, which is a real observer, not with respect to the plank, which is with respect to the ice surface, with respect to the earth. Okay? So in part A, we have to find the speed, the real speed of the girl with respect to the earth. How to find the speed of the girl? We have to apply the conservation of linear momentum. I will draw a figure. This is the plank. The plank is found on a frozen lake. There is no friction. Initially, both of them were at rest. So the girl starts moving with a velocity, let me call it Vg. It starts the girl moving with a velocity Vg. When the girl moves with a velocity Vg, the plank will also move because we have a conservation of linear momentum. So the linear momentum of the system is conserved. The linear momentum of the system is conserved. So we will get P is equal to P prime, or P before equals P after. قبل ما يبلش الجيرل موشن كان هي at rest والبلانك at rest, so P10. بعد ما مشيت الجيرل اوكي صار عندها هي speed الماس للجيرل times الفيلوسيتي للجيرل plus الماس للبلانك times the velocity of the plank. Okay, هلا each time the motion is along the same line. هلا هون أكيد ال VG وال VP they are opposite in direction، يعني وحدة لقدام وحدة لورا، because if I have to write them as vectors I will get V للبلانك equals minus mg over mp vg. So for sure they are collinear. I can use algebraic values. So use algebraic values. When we use algebraic values ما تحطوا انتو minus, just leave it as it is, and if it is negative it will appear. Okay, so use algebraic values. values, I will get 0 equals mg vg plus mp vp implies remember I'm searching for the velocity of the girl, so I'll try to find the speed of the plank and then substitute in the upper equation. So I will find VP it's equal to minus mg over mp vg, like this. So now I've found VP, I will substitute in the upper equation, which is VG minus VP equals 1.5, implies VG plus mg over mp VG is equal to 1.5. We have everything. I will get VG into 1 plus mass of the girl was given, it was 45, mass of the plank was 150, it's equal to 1.5. So I will get the speed of the girl to be 1.15 meter per second. So this is the speed of the girl. After finding the speed of the girl, now I can find the speed of the plank. So part B, the speed of the plank, it's equal, as you can see, it's equal to minus mg over mp vg. Okay, we have everything. I will calculate. Just give me 1 second. So 1.15 multiplied by 45 divided by 150, we will get minus 0.345 meter per second. That means that the plank will move opposite to the motion of the girl backward, okay, with this speed. So مثل ما شايفين هون بهيدا السؤال الجيرل مشيت باتجاه البلانك مشيت بالاتجاه المعاكس because the system اللي أنا كان عندي اللي هو البلانك مع الجيرل some الفورسز acting على هيدا السيستم is zero، مع عليه friction، مع عليه شيء، مع عليه friction. الفورسز acting on it are weight and normal. أكيد الweight and normal they add up to zero. أنا ما عندي motion على الvertical. So sum of forces acting on the system كله مع بعضه اللي هو الجيرل مع البلانك will be zero because the forces are the normal من الفروزن ليك وزائد الويت للجيرل مع الويت للبلانك. So these forces add up to zero because there is no motion along the vertical. Sum F equals zero along the vertical. That means sum of forces equals zero. That means the linear momentum is conserved. Problem 24, page 284. As shown in figure 9.24, a bullet of mass m and speed v passes completely through a pendulum bob of mass m. The bullet emerges with a speed of v over 2. The pendulum bob is suspended by a stiff rod of length L and negligible mass. What is the minimum value of v such that the pendulum bob will barely swing through a complete vertical circle? So we are searching for the speed of the bullet so that the pendulum performs a complete circle. I will divide this problem into two parts. The first part is collision. Bullet collides with the pendulum. بيرجع البندلوم بيكون تحت بيطلع لفوق. هيدي conservation of mechanical energy. Let me first apply the conservation of linear momentum for collision. Don't use the formulas of elastic collision because this is not an elastic collision and هو ما قال okay he must say it's an elastic collision. Use just the conservation of linear momentum and it will be fine. You will find the answer. So P is equal to P prime. Before collision كان عندي بس bullet in motion, so mv. The pendulum was at rest, so plus 0 equals bullet after collision it's mv over 2 and the pendulum it's m, I will call it v prime. Okay, so because they are all collinear on the same line, I will use algebraic values. So I will get mv equals mv over 2 plus mv prime. So mv over 2 equals mv prime implies v للبولت it's equal to 2 mv prime over m. This is the speed of the bullet in terms of the speed of the pendulum after collision. هلا لازم أنا إذا بجيب ال v prime بقدر أعرف السبيد للبولت. Okay, how to find the speed of the pendulum after collision? Remember that I need the pendulum to perform a complete circle. يعني أنا بدي البندلم يوصل على هيدي البوينت that I will call it T. So let me apply the conservation of mechanical energy. So conservation of mechanical energy رح تعطيني E mechanical initial it's equal to E mechanical final. Down it's equal to up. I will take the reference level for gravitational potential energy here. Okay. So down أول ما انطلقت البوب كان عندها سرعة اللي هي v prime. So ما كان عندها EPG. The only energy is the kinetic energy which is half mv prime squared equals. Finally لما وصلت لفوق it will have a speed half mvt squared plus mg height it is 2l because the length of the rod is 2l. I will divide by m everywhere. divide by m. هلا أنا بهمني إنه هي توصل على التي. لتوصل على التي أقلها لازم تكون السبيد at t 0. So to perform a complete circle, to perform a complete circle, VT minimum it's equal to 0. أقلها توصل على التي. Okay, so VT minimum is 0. So if I remember I'm searching for the minimum value of V, so I will use the minimum value of VT. I will substitute for VT 0. I will get راح أعوض بالequation V prime squared equals أكيد 0 equals 4GL implies V prime is equal to 2 radical GL. Okay, لقيت ال V prime. بعد ما لقيت ال V prime I will substitute it up in the upper equation to get V minimum. So V, which is the speed of the bullet, is equal to 2m over m times 2 radical GL. It's equal to 4m over m radical GL. ممكن حدا يجي يسأل حاله سؤال إنه نحن هون ليه ما حكينا عن N positive أو T positive. simply إنه نحن هون السؤال عنا pendulum is attached to a stiff rod. هي عبارة عن rod. so مستحيل يوقع. ما رح يوقع مثل لما يكون التنشن في عندي string أو في عندي ball moving inside a circle وهالبول مش معلقة بشي. so كرمال هيك أنا أخذت المينيموم سبيد على التي هي 0. أنا مجرد ما وصل هو على التي خلاص عمل complete circle ما في احتمال يوقع. بينما لما يكون attached to a string أو مش attached to أو attached to a nothing بس عم يبرم على circle so في احتمال يوقع. كرمال هيك أنا بفحص النورمال وبفحص التنشن. I will remind you لما يكون أنا عندي string مع pendulum okay and I'm searching for خليني أقول أنا عم فتش على السرعة at the highest point T. okay this is the point T, this is the highest point. على هيدي البوينت أنا عندي 2 forces which are the weight اللي هو mg وعندي التنشن. هلا أنا رسمته هيك كرمال بس okay وعندي التنشن. so this is the string projection راح يطلع معي أنا إنه T plus mg is equal to mv square ل T على R أو على L اللي بدكم إياه. so over L. أنا أقلها التنشن فيها تكون عندي 0 يعني التنشن must be positive. كان الكونديشن يكون عندي التنشن must be positive. so التنشن minimum إذا بتكون هي 0. so أنا فيني أجيب ال VT minimum من هالحالة. ال VT minimum بيطلع معي it's radical LG. هيدي فوق يعني أقلها لحتى تقدر تعمل complete circle لازم المينيموم speed فوق must be radical LG. إذا أنا عم بحكي عن particle عم تمشي بقلب circle وصلت البارتيكل لهون نفس الفكرة. عندي ال mg عندي ال r عندي ال n اوكي downward. so n plus mg must be equal to mv square على r لأنه على الراديال كل شيء على الراديال بيساوي ma normal. so أقلها ال n must be positive في condition ال n تكون positive. so ال n minimum هي 0. إذا ال n minimum هي 0 so ال v بهالحالة ال v على البوينت t أكيد هيدي على البوينت t ال v على البوينت t minimum بعوض 0 محل ال n بيطلع معي it's equal to radical gr. لاحظوا أنا it's the same answer بس هون r وهون l. لاحظوا إنه السرعة على ال highest point اللي هي t هي منا 0. it has a value which is radical lg. okay it's radical lg it has a value. بينما هون بهيدي الحالة it's 0 simply لأنه هون the ball is connected to a rigid rod. اوكي بهدول السؤالين مضطرة أنا استعمل condition T positive و N positive. بهيدا السؤال there is no need. so هون هيك أنا مثلا معي T minimum من T minimum فيني أربطها بعدين بتحت بده ياني أربطها بمطرح تاني بربطها باستعمال conservation of mechanical energy. اوكي so إذا أنا معي T على السبيد على البوينت T I can relate it to any point I like وخلاص فيني بشتغل بعدين. اوكي A 12-gram wad of sticky clay is hurled horizontally at a 100-gram wooden block initially at rest on a horizontal surface. The clay sticks to the block. After impact, the block slides 7.5 meters before coming to rest. If the coefficient of friction between the block and the surface is 0.65, what was the speed of the clay immediately before impact? So we have a clay like this. So the clay, assume it has a speed v. We are searching for the speed v before collision. This clay is going to collide with a wooden block. Okay, the wooden block was initially at rest, so when they collide they will stick together. Okay, they will stick together and move together with a velocity which is v prime. After collision, the block and the clay will move together a distance 7.5 meters before the system stops. Okay, so the system will stop at the end. So here at rest. So the problem is divided into two parts. Collision between the clay and the block. بعدين السيستم اللي هو clay block moves together till it stops. أول مرحلة بعالجها collision, conservation of linear momentum. تاني مرحلة بعالجها mechanical energy. هون because we have a friction, I will apply delta E mechanical equals work of a friction, which is the non-conservative force acting on the system. I will first start by applying conservation of linear momentum. I have to say something important. بهيدا البروبلم اللي أنا عندي إياه، أنا عندي two objects that are going to stick together. When they stick together, نوع الcollision هيدا perfectly inelastic collision. This is a perfectly inelastic collision. So بكل السؤال لاحظوا ما قال كلمة elastic, so I cannot use the conservation of kinetic energy. I cannot use the formulas that are found at the last slide of the lecture. So I have to use just the conservation of linear momentum and find the speeds that I'm searching for. So I will say that this collision is perfectly inelastic. ليه؟ because they stick together after collision. So let's apply. دايما بحيالله collision كان elastic, perfectly inelastic, partially inelastic, we always apply the conservation of linear momentum. So conservation of linear momentum implies P before equals P after. So P is equal to P prime. هلا before أنا مين عندي in motion؟ عندي the clay was moving, so I will assume the clay has a mass M1, the block has a mass M2. M1 is 12 gram and M2 is 100 gram. So I will say M1 V. The clay was in motion. The box or the block was at rest, so plus 0. It's equal. بعدين they stick together. I have to write M1 plus M2. Their speed after collision راح سميها V prime. So this is V prime. They are collinear. Everything is collinear. So I can remove the vectors and I can write M1 V equals M1 plus M2 V prime. Remember, I'm searching for V اللي هي the speed of the clay before the impact, before collision. I'm searching for V. بس ال V prime ما معي إياها. So I'm going to search for V prime using the second part of the problem, which is using the mechanical energy. Because we have a non-conservative force, which is friction, I will say that, so friction is the only non-conservative force. I will say that delta E mechanical is equal to the work of friction, which is the non-conservative force. So E mechanical final minus E mechanical initial, it's equal to work of friction. هلا finally لما وصلت finally this is final position and this is initial position. Finally مثل ما شايفين لا عندي EPG، ما عندي ما عندي elastic، ما في بسرعة، وما عندي kinetic. So finally it is 0 minus الاي ميكانيكال initial كان عندي بس kinetic وما كان عندي EPG وما كان عندي elastic. So it's half. السيستم كله سوا. So it's M1 plus M2 V prime squared لأنه صارت سرعتهم من بعد الكوليجن هي V prime. So I have to write V prime squared. It's equal to work of friction. Work of friction is equal as usual minus FR times D, distance travel. طيب ال FR I don't have it، ما معي إياها، بس أنا بعرف إنه لما يكون عندي هيك سؤال صرت حليتها مرات كتير. It's related to mu somehow. It's equal to minus mu. I'm in motion, so mu Kn times D. طيب الآن شو بتساوي؟ مثل ما شايفين انتو the forces acting on this block during its motion. I will draw it here aside. عندي الويت، عندي النورمال، وعندي الفريكشن. كل مرة البوكس بيكون على horizontal line مثل ما شايفين. مجموع الفورسز acting on the vertical is 0. So for sure بهيدي الحالة N it's equal to weight، لأن it's equal to mg. لما يكون على inclined plane ونفس الحالة عندي friction ونورمال وويت بيطلع معي النورمال mg كوساين ألفا. أوكي، هون لما يكون ماشي على horizontal line بيطلع معي N equals mg. For sure here I'm talking about the block مع الكلاي because both of them were moving together. Okay, so in this case I will substitute N for its value. I will get minus mu K. N it's equal to mg. نحن عندي السيستم تعولوا عنده الماس M1 plus M2G. So M1 plus M2 because I have a system G times D. Okay, so implies أنا صار معي minus half M1 plus M2 V prime squared equals minus mu K M1 plus M2 GT. I will divide by M1 plus M2 والماينس كمان. Okay, I will get V prime equals to 2 mu k g d for sure تحت الراديكال. معنى كل شيء معنى الميو k was given to be 0.65 الجي 9.8 والدي كانت معنا I guess 7.5. okay it was 7.5. نحسب كل الأرقام بيطلع معي 9.77 meter per second. so لقيت ال V prime. هلا أنا برجع عند الإيكويشن I will call this equation 1. برجع عند الإيكويشن 1 جبت ال V prime برجع بحط ال V prime بهيدي الإيكويشن وبجيب ال V اللي هي the speed of the clay before the impact or before collision. so then from equation 1 I will get أنا عم جيب ال V it's equal to M1 plus M2 over M1 V prime. the M1 was the the mass of the clay it's 12 plus M2 100 over 100. هلا ما حولت أنا ل SI unit لأنه جرام على جرام راح يطيروا مع بعض. اوكي وال V prime اللي هي 9.77 I will get my answer. which is equal to 91.2 meter per second. okay and this is for this problem. I will move now to problem 27 page 284. this problem says 3 carts of masses 4 kilogram 10 kilogram and 3 kilogram move on a frictionless horizontal track with a speed of 5 meter per second, 3 meter per second and 4 meter per second. You can see that this is M1. I will call them M1, M2 and M3. You can see that M3 moves to the left, M1 and M2 move to the right. So هون هو حاطط -4. هو معتبر ال positive sense أو ال x axis أنا معي to the right. so this is the positive sense. so كل شيء بيكون مع positive sense عنده positive speed لعنده negative speed must go opposite to the chosen positive sense or opposite to x-axis. Velcro couplers make the carts stick together after colliding. So they will collide and they will stick together. The type of this collision is a completely inelastic collision. Find the final velocity of the train of the 3 carts. So هون عندي 3 colliding objects. لو كانوا 2 أو 3 أو 4 أو قد ما كانوا they are colliding I also apply the conservation of linear momentum. This is an inelastic collision. So let's apply the conservation of linear momentum. So this is a perfectly inelastic collision. Apply conservation of linear momentum. Okay, so in this case P before it's equal to P after. Before كان عندي M1 V1 plus M2 V2 plus M3 V3. I'm writing them as vectors. It's equal. They all stick together, so they will form one system, M1 plus M2 plus M3 V. I will use algebraic values. When I use algebraic values, I will just remove vectors and I will consider that V1 and V2, they are not the speeds, they are the speed مع sign. Okay, the sign is included inside the velocity. M3 V3, it's equal to M1 plus M2 plus M3 V. So I will substitute for the numbers. I will get M1, it's 4 times 5. Okay, then you've got 10 times 3 plus it's 3 times -4. See that I've substituted V3 for -4. It's equal to, we add all of them, 4 plus 10 plus 3v. So we get v equals 2.23. Okay, and this is the answer for sure, meter per second. You can see that v is positive. لما يطلع مع ال v positive هيدا بيعني انه كريزلت الثلاثة when they stick together they will move to the right. Okay, because the sign is positive. لو طلع معي أنا رقم نيجاتيف هيدا بيعني لما ثلاثة يصطدموا ببعض رح يروحوا على الشمال. So this is the benefit of using algebraic values. أنا ما بعتلها من الساين، هي لحالها بتطلع معي plus أو بتطلع معي minus and I substituted يا plus يا minus depending on the chosen positive sense. Okay. بقول لي in part B, what if does your answer require that all the cards collide and stick together at the same time? What if they collide in a different order? If they collide in a different order أو they collide وحدة ورا وحدة, we will always have the same answer. Okay, so coupling makes no difference. This is part B. Coupling makes no difference. Okay, this is for problem 27. Now problem 33, page 285. This problem says a billiard ball moving at 5 meters per second strikes a stationary ball of the same mass. So both balls have the same mass. After the collision, the first ball moves at 4.33 meters per second at an angle of 30 degrees with respect to the original line of motion, assuming an elastic collision. So he's saying an elastic collision. Look, he's saying an elastic collision. And this collision is not a collinear collision. Why? Because we have an angle of 30 degrees. So this is a collision in reality in 2 dimensions. And ignoring friction and rotational motion, find the struck ball's velocity after the collision. So what do I have? I have a ball. This ball was moving with a velocity I will call v1. v2 was 0 because the second ball was at rest. v2 is equal to 0, it was at rest. After collision, the speed of the first ball, which is v1 prime, he said that it makes an angle 30 with the original direction. So this is angle 30. And v2 prime, I don't know how it is, so I will write it v2 prime like this. I don't know anything about v2 prime. He's asking to find the velocity of the ball after collision, or the velocity of the second ball after collision. Let's try to apply the conservation of linear momentum. Apply conservation of linear momentum. So P before it's equal to P after. I will get before and then M1 V1, okay, equals M1 V1 prime plus M2 V2 prime. Okay, هلا هون ما فيني طير الفectors لأنه أنا I'm moving in 2 dimensions. They are not collinear, so I will keep the vectors and I will write them in terms of I and j. Because M1 is equal to M2, I will divide by M1. So M1, remember M1 is equal to M2. And I'll try to write V1 as a vector. I will take x-axis like this with motion. This is x-axis. I will take y-axis perpendicular to x-axis to write them as vectors. And my V1, it has a magnitude of 5. So V1, it is 5i. Okay? Equals. The V1 prime had a magnitude of 4.33. So I will write V1 prime as 4.33 cosine 30i plus 4.33 sine 30j. هيك بكون كتبت الفيكتور اللي هي ال V1 prime. هلا ال V2 prime أنا ما عندي عنها معلومات. I will keep it as V2 prime. I will keep it like this. Okay, I will gather all of them to one side. So I will get V2 prime. I have already calculated it. I will get 1.25i minus 2.16j. so if I'm going to draw v2 prime, v2 prime راح تطلع معي as I have drawn it. عندها vx تعولة is positive vy تعولة is negative, so it's drawn the same way I have drawn it. If I'm searching for the angle, I can search for the angle between v2 prime and x-axis like this. So tangent theta, it's equal to minus 2.16 over 1.25. So I will get theta, it's equal to approximately minus 60. That means the angle here between x-axis and v2 prime, it is minus 60 degrees. And if I'm searching for the magnitude of the vector, you all know how to find the magnitude of the vector. So v2 prime as a magnitude, it's equal to radical 1.25 squared plus minus 2.16 squared. So I will calculate it. You will get 2.5 meter per second. Okay, we did not use the conservation of kinetic energy, so we were able to find our solution just using the conservation of linear momentum. Now problem 35, page 285. An object of mass 3 kg moving with an initial velocity of 5i meter per second collides with and sticks to an object of mass 2 kg with an initial velocity of minus 3j meter per second. So we have two objects. The first one has a mass, I will call it m1, 3 kg, and it has an initial velocity v1 equals 5i. The second one has a mass m2, it's equal to 2 kg, and it has an initial velocity v2 equals minus 3j. This collision is not collinear because one vector is along y, the other is along j, so both vectors are making an angle of 90 degrees between them. So this is a collision in a plane and not a collinear collision. So he's asking to find the final velocity of the composite object. Because the two objects are sticking together and moving as one object, this is a perfectly inelastic collision. I cannot use the conservation of kinetic energy. أصلا هو بالسؤال ما قال لي كلمة elastic collision. I only use the conservation of linear momentum, and that shall be enough to find the answer. Okay, so the two bodies combine. Combine together implies totally or perfectly inelastic collision. If it is a perfectly elastic collision, if it is a collision, I can use the conservation of linear momentum. So apply the conservation of linear momentum. So P before is equal to P after. Before I had two objects, both of them were moving, so m1 v1 plus m2 v2. They stick together, so I write them as one system. I will write them m1 plus m2, and I will call the velocity after collision v prime. Okay, so I just substitute. I have m1, it's a 3, v1, it's 5i. I don't use algebraic values, I keep them as I and j because I'm working in a plane. So plus m2, it's 2, v2, it's minus 3, j. m1 is a 3 plus 2, I get 5, v prime. So it's obvious that I will divide by 5 to get v prime. It's equal to 3i minus 1.2 j. Okay, this is v prime. If he's asking for the speed, which is the magnitude of the velocity, so if he's not asking, but I'm calculating them anyway. So v prime is equal to radical 3 squared plus 1.2 squared it's equal to, I will calculate it, it is 3.23 meters per second. Okay. We may add a part, let me call it part B. The part says check that the collision is inelastic. Collision is inelastic. How to check if the collision is elastic or not? I have to check the kinetic energy before and the kinetic energy after. If they were equal, then it is an elastic collision, and if they were different, it is an inelastic collision. بس أنا بعرف already إنه هذا راح يكون an elastic collision. So anyway, let's check if they are equal or not. I will check with you. So the kinetic energy before collision, EK, equals half m1 v1 squared plus half m2 v2 squared. It's equal to m1 was given to be 3, v1 was 5 because it's 5I, so for sure the speed is 5 squared plus half m2 was 2 and it was minus 3, so its magnitude is 3, so it's a 3 squared. I will calculate. I will get 46.5 joule. Okay, let us calculate the kinetic energy after collision. After collision they form one system, so it's half m1 plus m2, I've called v prime squared. It's v prime squared, no need for the vector. It will give me half m1 plus m2, which is 3 plus 2, which is 5 for sure. V prime squared was found to be 3.23 squared, so we will get 26.08 joule. So you can see that we have a loss of kinetic energy. This loss is due to sticking of both objects together. Okay, so our collision is clearly inelastic. So EK prime is less than EK. This is for this problem. I will now solve problem 67, page 289. This problem says a 9-gram bullet moving with an initial speed of 400 meters per second is fired into and passes through a 1 kilogram block, as in figure 9.67. The block, initially at rest on a frictionless horizontal surface, is connected to a spring with force constant 900 Newton per meter. If the block moves 5 centimeters to the right after impact, find the speed at which the bullet emerges from the block. The mechanical energy converted into internal energy in the collision. I will talk about internal energy. It's not required, but I will talk about it anyway. It's something obvious and it can be easily deduced. Okay, so as you can see here, our problem is divided into two parts. The first part, the bullet collides with the block, and the second part, the block compresses the spring and arrives to a maximum compression of 5 centimeters. Okay, after the impact. So I will try to apply the conservation of linear momentum first, then I will apply conservation of mechanical energy, because in this problem we have a frictionless surface, so there is no friction, no non-conservative forces. I can apply the conservation of mechanical energy for the block alone. Okay, pay attention that this is a partially inelastic collision because the bullet collides with the block and then it leaves the block, so it passes through the block. هيدا بيعني انه يعمل deformation للبlock, so for sure this will be a partially inelastic collision. So بس ما يقول بالسؤال elastic collision, don't think about an elastic collision unless he says that. Okay, he must say this is an elastic collision so that I can use the formulas of a collinear elastic collision. So let's start first with the first step, which is the collision between the block and the bullet. Initially, the bullet had a speed of 400 meters per second. I will call it V1 equals 400 meters per second. The block was at rest, so V2 is equal to 0. After collision, the block will move with a velocity V2 prime, this is for the block, while the bullet will move with a speed, I will call it V1 prime, which is the speed of the bullet after collision or impact. Okay, I don't have the speed of the bullet after collision, I'm looking for it. So we are searching for the speed of the bullet after collision. Let me apply the conservation of linear momentum. So apply conservation of linear momentum. So I will get P before is equal to P after. Before, I've got mass of the bullet times V1. Okay, the block was at rest, so it's 0 equals, after collision, it's the mass of the bullet, it's a small m, I'm calling it as a small m, and V1 prime, this is the speed of the bullet after collision, this is what we are looking for. Okay, we are looking for V1 prime plus big M, which is the mass of the block, I've called it V2 prime. Okay, so this is a collinear collision. I can use algebraic values without vectors, so mv1 equals mv1 prime plus mv2 prime. Remember, we are searching for v1 prime, so v1 prime, it's equal to v1 minus m over m v2 prime. لحتى أقدر أنا أعرف ال v1 prime مع ال v1 which is the speed of the bullet before collision, I still need v2 prime اللي هي سرعة البلوك بعد الكوليجن. طب how to find the speed of the block after collision؟ بعد الكوليجن البلوك راحت وعملت maximum compression, so I can apply the conservation of mechanical energy for the block. So apply conservation of mechanical energy for block. So I will get for sure E mechanical initial equals E mechanical final. I mean E mechanical initial after the collision, من لما انطلقت بعد الكوليجن لحد ما عملت maximum compression. So أول ما انطلقت كان عندها بس kinetic اللي هي half big M, which is the mass of the block, V2 prime, which is the speed of the block بعد الcollision squared, equals عملت maximum compression, so it's half kx squared. Half with half is cancelled. I have the mass of the block. The mass of the block was given to be 1 kilogram, so it's 1. I'm searching for V2 prime squared. K was given to be 900. X is the compression, is 5 centimeters, so it's 5 times 10 to the power minus 2 squared. I have calculated V2 prime on my own, and it turned out to be 1.5 meter per second. So I found V2 prime. After finding V2 prime, now I can find V1 prime. I will substitute in the equation above. So V1 prime, it's equal to V1 was 400 minus M is the mass of the block, it's 1, over small m is the mass of the bullet, it's 5 times 10 to the power minus 3. Okay, don't forget to change to SI units. V2 prime, it's 1.5, so I have everything in SI units. Now I can find V. It turned out to be 100 meters per second. This is the speed of the bullet after collision. So in part B, he asks for the mechanical energy converted to internal energy. You all know that this is a partially inelastic collision. So I will write In part B, this is a partially inelastic collision. Why? Because the bullet deformed the block, it passed through the block, okay, and it did not stick to the block. If the bullet sticks to the block, this is a completely inelastic collision. لما يخرق البلوك ويظهر من تاني جهة عمل deformation, so there is loss of energy. This is a partially inelastic collision. So in this case, for sure, we have loss of kinetic energy. The kinetic energy is not conserved. By definition, okay, you are not responsible for the internal energy, but I will explain it, because you are responsible for the variation of the kinetic energy, and here he's asking for the variation of the mechanical energy or the variation of the internal energy. I will tell you that the internal energy, which is delta U, it's equal to minus delta E mechanical. That means if the collision is inelastic, we will lose kinetic energy or we will lose mechanical energy. The mechanical energy lost during a collision, okay, is transformed to other types of energy such as heat, deformation, sound. So we can say that the energy is transformed from our system to the environment which is beside this system, which is surrounding this system. We can say that the mechanical energy is changed to internal energy. We are not responsible for internal energy. We're only going to calculate the variation of mechanical energy. So minus delta E mechanical is equal to minus delta EK. I don't have to worry about the potential energy because I'm looking for a variation of mechanical energy قبل وبعد الcollision. So ما لحق يمشي قبل وبعد الcollision, directly just before, just after. This is how to test an elastic أو inelastic collision. Just look before and after collision. بعدين شو بيصير? We can treat it separately. So it's equal to minus delta EK. It's equal to minus EK after, it's half M1 V1 prime squared plus half M2 V2 prime squared minus before عندي بس البولت كانت in motion, it's half M1 V1 squared. So we've got everything. If we calculate this, we will get 373.87 okay joules. So this means that we have lost 373 joules as mechanical energy. This energy was gained by the environment which is surrounding this system.